So conditional probability is probability of one event occurring given that another event has occurred. All right, so it's provided additional information. And what it overall does is it's going to change the sample space. See now probability is the number in our event over the number in the sample space. Well, it's going to change the sample space to a different total. That's pretty much what it does. So to figure out what conditional probability is, let's look at this Venn diagram. I've got a sample space, I've got sets A and B, they have an overlap. And it could have been numbers or letters, I just put some dots in there to represent elements. Let's figure out the probability of A occurring given that B has occurred. Now here's how we're going to write this. Probability of A given B. You're going to put like a vertical line there, a bar that represents given. You just want to write that means given. So we read this as probability of A given B. So to get that, let's look at the Venn diagram. Basically, we're in B. I'm going to circle. This is the new sample space. I mean, B is in S, but we're provided the information that we are definitely in B. So all these others outside, we're done with, right, for this question. So we're in B. So then let me ask you this. We're finding the probability of A. Describe what part of that in red, in B, what part of that is A? Yeah, the middle part, the overlap. Right, this here is the only part that has A in it. It's the only part of it. Now, yesterday, what did we call the overlap? What was that? It was the and. Yeah, it was the and. And so this will be our formula. It's the part to the whole, the number in our event we want. The A part is the intersection. So what this becomes is the intersection, the number of terms in A and B, over the number of terms in our new total, which is B. It's no longer the sample space, it's just B. That's the formula for conditional probability. And in B, it says generalized to probabilities. I'm just going to tell you the note right here.
So B would
B is the new sample space.
Part?
I'm sorry?
Would not be in the middle part.
Well, yeah, this is A and B is the middle part. The green is part of B as well. But it's the only part we're provided we're in B, so the only part that has A in it is the intersection. And so the new total we're in B, that's the total on bottom, the new sample space. Okay. This formula is not on the formula sheet, so you will have to know this one. So it's generalized. You can do it as numbers with N, or you can do it with P, probability, either one. You notice here they wrote the symbol as well. It means N, so either one. And I will make a note here as well. If they did it could be any letters, right? Even if they went backwards, what it becomes, if you forget, think of the Venn diagram. Or if you just want to memorize the formula, you're in A, so that goes on bottom. Whatever the second one is, you're in that, so that's the total on bottom. And then the numerator is the intersection of these two. The number, so you can still write it as A and B, or you can write it as B and A. Doesn't matter. All right. And then before we try some, right here I said the table questions for these, they're actually not that bad. You can just look at the table. You look at the intersection. Conditional probability, if it's a word problem, you got to use the formula. So, all right, anything you can answer before we try an example or two? Yes?
So is it like total over part?
No, it's part to the whole, but this is the part. The intersection is that, just in green. And then B is in the red there. That's the total. It's still the part to the whole. It's just the part we want. And think about it. It says we want the probability of A given B. So the A part is what we want, and the only part that's A is that overlap, which we call A and B. So, I mean, we want A, but the only part that's A is the intersection A and B. So, nice. So let's try this one. It's the same table from yesterday. It's the 52 students surveyed, graduating seniors, male or female, going to college, not going to college. All right, same one from yesterday. I'll do one or two. These are actually, the first row here is actually all review. Find the probability. Let's do one or two of those, and then I want to get to the given ones. Probability of female. Female, this one already has the totals in it. 22, and there was 52 total. Yeah, 52 total. So 22 over 52. Let's just do one more. We'll do May. Oh no, let's do college. Probability of going to college, 29 out of 52. So that was a review. I could have also put an and or an or question in here as a review, but let's do some conditional ones. First one, probability of C, college, given female. Now I'm just going to do it from the table, but I will show you how I really am using the formula. Probability of college given female. So we are in the female column. That's the new sample space. The probability of getting a student that is going to college, right? If I'm that row, 13. What's the total? Only 22. Because that's the new sample space. We're female. We're not in the entire student's 52. That's it. They're pretty easy for those. So you, given female, I box that column. Probability of college for female is just a 13 out of the new total of 22. I do want to show you real quick. I really am using the formula. So if I was doing the formula on this one, I do the intersection, probability of C and F, over, number. Number in C and F, over the number in female. And we listed both those right there. College and female, there's 13. Female, 22. Okay, so I really did use the formula. It's kind of easier though just to go look at the table. Okay, that's the first one. Any thoughts on that one? That's not too bad. Let's try two others just to make sure the table. In given M, so that's probability of not going to college given that you're male. So there's male. Probability of in not going to college is the 14 out of the 30. I can reduce that. Let's just keep moving though. So 7 over 15, I guess, if you want, or as a decimal percent. Okay, one more. Female given college. So probably, okay, so given college, they're going to college. I'm in this row now. Probability that they're female, 13. I should say number of female, 13 over the number that are college, 20. Table ones, I don't think those are too bad for conditional. I want to do one word problem type though. So, any thoughts on the table version? Not too bad. Okay, so again, I'm just doing number one from the practice now so that it has a word problem example instead of another table one. Okay. So, on this one, we're at Arlington High School, 650 juniors. That's our total right now for juniors. But 468 are enrolled in Algebra 2. 292 are in physics. 180 are taking both courses at the same time. If one of those 650 juniors was picked at random, what's the probability they're taking physics if we know they are in Algebra 2? And we should translate that to mean the given. Right? Other than say the word given, that says, all right, if they're taking physics, if we know, that's given, provided, we know they're in Algebra 2. So here's what we're really finding. The probability, I'm going to say physics is PH and Algebra 2 is just A. We're finding the probability they're taking physics given they're in Algebra 2. So this is a given question. I'm using the formula. Now again, you can always do, depending on, they give us numbers here. They've given us probabilities, it'd be probability, but I'm going to be numbers here. So it's the number of the intersection, number that are in physics and A, algebra 2, over the number in our new sample space N. I say N? A. Number that are in A, algebra 2. We have both those. Physics and algebra 2. I think it's 180. 180 are taking both. That's physics and algebra 2. Divided by the number taking algebra 2. Yeah, I think it's around 468. Okay, that's it. So for this, you really do have to use the formula. Now, a good question came up earlier. They said, well, do I have to write this? Well, no, if you know it's this, you're just kind of doing it in your mind, like that's the intersection over total. That's fine, you don't have to write this. I'm just writing it out so you know what formula I'm using. Okay, and then on this one, that could be reduced as a fraction. I think I just made it a decimal though. Yeah. It's about 0.38, made it easier. Or you can do 38%. One other thought on this one, the 292, you don't even use. Now, if they ask us, what's the probability somebody's doing algebra 2, given that they're in physics, then we would have used the 292. Okay. Could I answer any questions on that one?